Hi. Everybody's racing to publish MCP servers so business users can orchestrate workflows with natural language. But every MCP server needs an API and real business logic behind it. Presuming you have an existing database, what about that MCP server? It should be as simple as pointing at a database and describing the logic in natural language. With MCP and Copilot, we can actually do that. Let me show you how. We issue this command. The system now reads the schema and creates a complete project and opens it in VS Code. The API, the UI, and MCP all wired up. But of course, we require logic. We declare natural language to Copilot, and it creates the rules. Notice the rules file. This is DSL, domain-specific language, not Frankencode. 5 lines convey what AI would need hundreds of lines to accomplish. Like a spreadsheet, the engine handles ordering, dependencies, reuse, and optimization automatically. And now, using MCP Discovery, we can use Copilot to test the update. The engine changes the logic, item to order to customer, and blocks the change because that would exceed the credit limit, exactly as declared. Notice how Copilot even explains the rule firing. That's governed execution. And this raises a question you might be wondering about. Why not just have AI CodeGen all of this? So we tried it. We asked AI to implement these same 5 rules procedurally. It generated over 200 lines of procedural scaffolding, dependency management glue, and we discovered 2 correctness bugs, overlooked transitive dependencies. And then something amazing happened. The model documented its own failure. LLMs cannot track all the dependency paths well enough to generate correct procedural code. And the important thing is this wasn't a model weakness. The model said the limitation was structural. So a better model wouldn't fix it. Complex dependency graphs are outside the comfort zone of AI models. And the research echoes the same thing. LLMs are great at patterns, but they break on multi-step, stateful dependency change, exactly what business logic is. And when you step back, you see why. Procedural glue is opaque, and every change forces full regeneration for dependency management, risking new bugs each time. That's evolution pain. And intuitively, you want AI to run SQL, not create a DBMS. Here, we want the rules, not the raw code we used to have to write. That's the difference between procedural GenAI, which produces fragile scaffolding, and declarative GenAI, where AI expresses intent and the engine ensures correctness. So the architecture becomes simple. AI expresses intent as DSL rules, the engine handles ordering, propagation, and constraints, and MCP becomes reliably governed. That's why we use AI for what it's great at, translating logic into DSL with dependency management in the rules engine. This delivers both agility and correctness, which is non-negotiable for enterprise AI. Try it yourself. It's free and open source. And get in touch. We love the feedback. Thanks for watching.